Hi class, let's take a look at example 2. Now on example 2, they want us to rewrite the histogram as a probability distribution. So just to clarify, when we're talking about a probability distribution, we're looking at a table that has outcomes and then also it's displaying probabilities associated with these. So what we're going to do here is a table where we translate this data, and then what I'm going to put is, well, let me start with the title. In this case, number of children. Part of the probability distribution is actually to define the values that we're using. So in this case, this is going to represent the x's, and then this is going to represent the probability of each. Notice that your x's go from 0 to 8. So you're going to have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then we're going to write for each of these the actual decimal representation that is actually provided on the top of the histogram. So for instance, for the first one, we're going to get that this is 0.273, and I'm referring to that value there. Then 0.160, which is our second one, then followed by 0.244, and then we're just going to complete each one of the values all the way to the bottom. So the next one is going to be 0.154, 0.082, 0.039, 0.020, 0.011, and then the last one, it's going to be 0.017. So we're just pairing up each of your x's or your random variable in here. And here I'm following basically the values from 0 to 8, nothing's missing. And then each one of the probabilities gets paired up on the table. That's pretty much it for a probability distribution. We're just using each of the values and the actual histogram. For part B, they want us to evaluate the probability of x is equal to 2. Now, x is equal to 2, this is your x value. In this case, the probability associated with this event, it's 0.244. And there's no calculation needed for this part B. We're basically just retrieving the value that's on the table. That would also be this value here. That's actually it for example 2.